Myself, Mr. Birajdar Balasaheb, Assistant Professor, Department of Humanities and Science, Walchand Institute of Technology, Solapur. In this video lecture, we will discuss Lagrange's interpolation formula part 1. Learning outcome. At the end of this session, students will be able to estimate the value of function at any intermediate value of independent variable by using Lagrange's interpolation formula. Now, what is meant by interpolation? The process of estimating the value of function y equal to f of x corresponding to any intermediate value of x from the given range is known as interpolation formula. Now let us start with Lagrange's interpolation formula for set of n points. Suppose we are given the following values of y for a set of n values of x in tabular form. The values of x are denoted by x0, x1, x2, x3 and so on xn, and corresponding values of y are denoted by y0, y1, y2, y3 and so on xn. When the value of x are not equally spaced, then the Lagrange's interpolation formula to fit the polynomial y equal to f of x is given by y equal to y0 into in numerator in bracket x minus x1 into bracket x minus x2 into dash 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 in bracket x minus xn divided by in bracket x0 minus x1 into bracket x0 minus x2 into dash 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 in bracket x0 minus xn plus y1 into in numerator in bracket x minus x0 into bracket x minus x2 into dash 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 in bracket x minus xn upon in bracket x1 minus x0 into bracket x1 minus x2 into dash 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 in bracket x1 minus xn plus dash 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 plus last term yn into in numerator x minus x0 into bracket x minus x1 into bracket x minus x2 into dash 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 in bracket x minus xn minus 1 upon in bracket xn minus x0 into in bracket xn minus x1 into bracket xn minus x2 into dash 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 in bracket xn minus xn minus 1. This is the formula of Lagrange's interpolation formula for given set of n points. Now let us pause the video for a while and write answer to the question. The question is, write a formula of Lagrange's interpolation for the set of 3 points given in tabular form. X values are x0, x1, x2 and y values are y0, y1, y2. Come back. I hope you return answer to this question. The required formula of Lagrange's interpolation for a set of these 3 points is as given below. Y equal to y0 into in numerator in bracket x minus x1 into in bracket x minus x2 upon in bracket x0 minus x1 into in bracket x0 minus x2 plus y1 into in numerator in bracket x minus x0 into in bracket x minus x2 upon in bracket x1 minus x0 into in bracket x1 minus x2 plus y2 into in numerator in bracket x minus x0 into in bracket x minus x1 upon in bracket x2 minus x0 into in bracket x2 minus x1. So this is the required formula of Lagrange's interpolation for a set of 3 points. Now let us consider one example. Using Lagrange's interpolation formula, estimate the value of y at x equal to 2 for the given data. X values are x0, 1, 3 and y values are 5, 6, 50. Solution. Here 3 points are given. These points are denoted by, let x values are denoted by x0 is equal to 0, x1 equal to 1, x2 equal to 3 and the corresponding values of y's are denoted by y0 equal to 5, y1 equal to 6 and y2 equal to 50. We know that Lagrange's interpolation formula for set of 3 points as y equal to y0 into in numerator x minus x1 into x minus x2 and in denominator x0 minus x1 into x0 minus x2 plus y1 into in numerator x minus x0 into bracket x minus x2 in denominator in bracket x1 minus x0 into bracket x1 minus x2 plus y2 into in numerator in bracket x minus x0 into bracket x minus x1 upon in denominator in bracket x2 minus x0 into bracket x2 minus x1. Now in this formula substitute the value of x0, x1, x2 and y0, y1, y2. So x0 is 0, x1 is 1, x2 is 3 and y0 is 5, y1 is 6 and y2 is 50. When we put these values, we get y equal to 5 into in bracket x minus 1 into bracket x minus 3 and in denominator in bracket 0 minus 1 into bracket 0 minus 3 plus 6 into in numerator in bracket x minus 0 into bracket x minus 3 and in denominator in bracket 1 minus 0 into 1 minus 3 plus 50 into in numerator in bracket x minus 0 into in bracket x minus 1 upon in bracket 3 minus 0 into bracket 3 minus 1. Now we have to find the value of y at x equal to 2. Therefore, we have to put x equal to 2 in above equation. We get y at x equal to 2 is equal to 5 as it is and in numerator x is 2. Therefore, in bracket 2 minus 1 into bracket 2 minus 3 and the simplification of denominator 0 minus 1 is minus 1 and 0 minus 3 is minus 3. The product is 3 plus 6 into in numerator 2 minus 0 into bracket 2 minus 3 and in denominator 1 minus 0 is 1 into 1 minus 3 is minus 2. The product is minus 2 plus 50 into in numerator 2 minus 0 into bracket 2 minus 1 and in denominator 3 minus 0 it is 3 and into 3 minus 1 it is 2. The product is 6. Therefore, y at x equal to 2 is equal to 5 into in numerator 2 minus 1 is 1 into 2 minus 3 is minus 1. The product is minus 1 and divided by 3 as it is plus 6 into in numerator 2 minus 0 is 2 into 2 minus 3 is minus 1 and product is minus 2 and denominator minus 2 as it is plus 50 into in numerator 2 minus 0 is 2 into 2 minus 1 is 1. The product is 2 and in denominator 6 as it is. Therefore, y at x equal to 2 is equal to the first term minus 5 by 3 plus in middle term minus 2 gets cancelled. We get 6 and plus 50 into 2 by 6 is 1 by 3. Therefore, 50 by 3. And when we take LCM 3 in the right hand side, we get y at x equal to 2 is equal to in numerator minus 5 plus 18 plus 50 divided by 3. Therefore, y at x equal to 2 is equal to, the sum of numerator is 63 and divided by 3 as it is. It gives the value of y at x equal to 2 is 21. So, this is the required answer for the given question. To prepare this video lecture, I refer this book as a reference. Thank you.